Hey everybody, hope you're having a great day today. Today we're going to work on standard deviation. Standard deviation is a measure of variation. It is very similar to MAD, what you guys did last year, mean average deviation. It's similar to that, and if you remember that, it takes a while to do, so we're not going to do too many of them. And all you got to do is kind of see this process here, these steps, and you'll be all right if you follow those. So what we have here, it says the standard deviation of a numerical data set is the measure of how much a typical value in the data set differs from the mean. The symbol sigma represents the standard deviation, and it's going to take that. So basically what you're doing is you're finding the average. Remember, x to the line over it means the average, or the mean. And then you're finding the deviation, or the difference, between each data point and the average. Okay, and then you're taking that difference, you're squaring it, you're adding them all together, and then dividing it by how many there are. That number is called the variance. And then once you have that variance, you then take the square root of the variance. Okay, so that is the process that we're going to go by. So first thing we have to do here is we have to find the average of show A. It says find the standard deviation of the ages for show A. So if you remember this from yesterday, we found the range. So today we're going to find the standard deviation. So if you want to pause the screen and find the average on your own, you can. But if you just want to hang out with me, I'll tell you that the average is 25. So when you add them all together, there is 300 when you add them all. There's 12 total. So 300 divided by 12 is 25. So now what we're going to do is we're going to find the difference between each one of these values and 25. Now if you look back to the directions, they say, you have to find you take the point, you subtract the average, and then you square it, right? So we're going to find the difference between each one of these points. Now, since we're going to square it, it doesn't matter if I do 25 minus 20 or 20 minus 25, because if I do 25 minus 20, I get 5. If I do 20 minus 25, I get negative 5. But either way, you're going to square it, so you get 25. So even though, that is the formula, if you want to kind of just see what the difference is, like between 25 and 20, you just know that it's 5. All right, so that's just the difference between those two. This would be 6. This would be 0, 2, 5, 4, 4, 3, 2, 4, 5, and 6. So that's the difference between all of them. If you want to follow exactly how it is, this would be negative 5, this would be negative 6, this would be negative 4. Anything less than 25 would be negative. But we are going to square it, so it's going to end up being the same thing anyway. So what we're going to do now is we're going to square each one of these, and then we're going to add them together. So 5 squared is 25, plus 6 squared is 36. 0 squared is 0, so I'm not going to write that. Plus 2 squared, which is 4, and if you can tell I'm going down this line here, 5 squared again is 25. 4 squared is 16. 4 squared again is 16. 3 squared is 9. 2 squared is 4. 4 squared is 16. 5 squared is 25. And 6 squared is 36. Alright, so you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 total values here. Plus we had 0 squared, so that would have given us 12. So that works. So we're going to add these all up, divide all of them by 12, and then take the square root. So this is where your calculator work will really come in handy, because you want to transfer the answers over. So what we're going to do now is we're going to add these all up in the calculator. So when we add all of these up, we get 212. So I have the square root of 212 divided by 12. So when I do 212 divided by 12, I get 17.7. So remember, the number inside here, when you get, it's called the variance. So if they ever ask you for the variance, it's 17.7 is the variance. And if you take the square root of the answer, it's 17 and 2/3. So I'm going to actually find the square root of that. It's about 4.2 is your answer. So the standard deviation is about 4.2, which means that the average contestant in show A differs from the mean by an average of around 4.2 years. So the standard deviation is, it's kind of just saying how much each one of these ages differs from the average on it, basically. So that's what the measure of variation is for this. So as you can tell, it's a bit lengthy, so we're not going to do too many of these. I'll only give you one for homework. And there's just one more thing we have to do, which is talking about data transformations using addition and using multiplication. Basically all it's saying is if you have all of your measures of center and variation, if you add a value to it, so when a real number k is added to each value in a numerical data set, the measures of center of a new data set can be found by just adding that value to the original measures of center. So to find the average, if you find the measure of center, meaning the mean, median, mode, if they say that you're adding 2 to every single data set, well then you would just add 2 to the mean, median, mode. The measure of variation of the new data set would be the same as the original. It wouldn't change because everything's still going to be the same distance away. If you're using multiplication, so in each value of a numerical data set is multiplied by a real number k, where k is greater than 0, the measures of center and variation can be found by multiplying the original measures by k. So if they say that all the numbers are doubling, then you just multiply the mean, median, and mode, all of those, by 2, and then you'd find the new values in the data set. Alright, so here it says consider the data example 1. So I have copied, pasted that, kind of hard to see here. But so it says find the mean, median, mode, and range of standard deviation when each hourly wage increases by 50 cents. So basically they're saying that we're going to add 50 cents to all the pieces of data that we had originally. And so then what would this change? So if you're adding 50 cents, all that's going to happen is it's going to change your measures of center, which are your mean, median, and your mode. So each one of those, mean, I'm going to type this. The mean would become, since we are adding 50 cents, it would be $10.15. The median, if we're adding 50 cents, would become $9.20. And the mode would become $8.75. Now, what would happen to the range and standard deviation? Well, since we're adding, we're not changing those at all. So the range would stay at 850. And standard deviation, which is called SD to abbreviate. I know you guys like your abbreviations. Would just stay at 261. Oh, it was 825, sorry. And the standard deviation would stay at 261. Alright, so that's how A would be. Nothing would change in terms of the measures of variation, but the measures of center, everything would add 50 cents to it. Alright, and for B, I'll just put that there. So we have to find the mean, median, mode, range, and standard deviation when each hourly wage is increased by 10%. So when it's multiplied, that means that everything gets multiplied. Since it's increasing by 10%, we can multiply each one of these values by 1.1. That would be increasing it by 10%. If you wanted to, you could multiply it by 0.10 and then add it to the original value. That's another way of doing it, but a faster shortcut is to multiply each by 1.1. So this would become $10.62. The median, when you do 870 times 1.1, you get $9.57. For the mode, you would do 825 times 1.1, which is $9.08 around. The range would wind up being the same thing, $9.08. And the standard deviation would be 2.61 times 1.1, which is 2.87 or $2.87. All right. So that's pretty much the lesson for today. So there's going to be a couple problems on big ideas, so give those a try. If you have any questions, make sure you attend the Google Meet. Other than that, have a great day.